Hey guys, welcome back to another training video. Today we're going to go over how to thread single point style using a lathe just like this one or exactly like this one. We're going to start by going over the controls, and then we're going to switch over and look at the tooling that we're going to need, and then we're going to go over the process, and we're going to do a lot of filming where we're just running. Now, I know you guys remember this plate from before. Remember down here, all these ones are used for your automatic feeds. Well, now it's time we start using these two boxes right here. Now, the size bolt we're going to be trying to make, or the size threads we're going to be trying to make, are going to be American or SAE, and we're going to try to make a 1-inch thread by 14 threads per inch. So we're going to go ahead. It doesn't really matter about how thick your bolt is. We're really worried about the threads per inch, okay? So we're going to come down this list, and you can see all these numbers here. These are indicating how many threads per inch you're going to have. So we need 14 threads per inch. So we're going to go down this list and we're going to find 14 threads, and you can see we see it right here, 14 threads. I know it's a little bit hard to see, but that's just the 14. Next, we're going to slide our hand over to the right, and you can see you got L, B, T, 8. These are the settings to which you need to set the machine up to. I want to point out this knob right here. If you notice, it's got an L and an H up here. Now, the first letter that we found on our numbers over here was L, right? Well, that's indicating this L right here, and you can see the little indicator. You want to make sure it's all the way turned to the left, okay? Typically, this knob doesn't get changed a lot. I think you'd have to be doing like a really coarse thread that you won't see very often, okay? Now we're going to zoom in because all of the controls we need are right here. All right, so now we just got to go ahead and get these dials all correct, right? Now remember, the first thing we had to do was we had to put it into Roman numeral number 2. If you had to per se put it into Roman numeral number 1, it's over here on this dial. I know, that's horribly confusing, isn't it? So the first thing I'm going to do is I'm going to grab this lever, I'm going to move it over. Now notice it's kind of hard to move over. Sometimes what you got to do is just spin the chuck and it moves easy. That's all you got to do. Remember, there's no clutch on this, it's all direct drive. So you just got to go ahead and spin that over. So now we got that one in the Roman numeral number 2. We're going to go ahead to the next letter, which remember was that L for low, and it's already in L, so we don't need to worry about that. Next, we're going to go to the B. Now, B is actually found over on this knob, so we're going to go ahead and move it over. Sometimes it looks like, kind of just feel the detents. There we go. So now we're in the B, and the next letter after B will be putting in the T, and it's already in T, so we're good there. And at the end of all of the letter number sequencing is a number. So that's when it brings us down to this dial over here. And we need to be in letter or number 8. Sometimes it doesn't like to go around one direction. Sometimes you have to go a totally opposite direction. Make sure you're always spinning that chuck. Otherwise, that's the whole process right there. So on a typical day where we're doing a lot of threading, I have to troubleshoot why the machine isn't running quite a bit, and it all comes down to making sure it's in gear, and sometimes you got to play with all those levers. But the best telltale sign of whether it's in gear or not is this nut, or this threaded rod right here will be spinning. So let's go ahead and click it on. Notice it's spinning. I hope you can see that in the video. Sometimes that won't be spinning, all right? And all that happens is, let me hit that brake. What happens is we have these 2 half nuts that clamp onto this thread here when we want it to travel, and the speed that this is spinning at gives us the travel rate that we want. So if you put it in gear and it's not working, flip it on and see if this rod's spinning. Same thing goes for if you're trying to set up the automatic feed. That's done off of this rod right here. So if your automatic feed's not working, check and see if this rod is spinning, and if it's not, play with those gears, play with those levers a little bit more, okay? Now, let's go ahead and move on to the tools. The 2 tools that are needed to do this job are, one, a threading bit with a carbide insert. It's going to look like that. This is the one that we're going to be using. The other one is we're going to use a parting tool to create our relief, and it's going to look like this. You want to make sure that you inspect these tips of both of these, make sure that they're not ruined, all right? So now we're going to go through the process of installing our parts, installing our tools, and actually cutting our relief back, and then going ahead and starting those threads, all right? Okay, so like I said, we're going to be cutting a 1-inch bolt with 14 threads per inch. Now, I'm going to be starting with a piece of rough stock that's already 1 inch, because I don't want to spend all the time to get it down to size just to show you guys how to thread really. But here's a quick tip though. If you're cutting any different size and it's not already brought down to the dimensions, and even if it is the dimensions, you want to bring it down 10/1000ths of an inch smaller than the actual diameter you're trying to cut, okay? All that does is it makes it so it's not quite perfect. There needs to be a little bit of a play in there. I would highly recommend 5 to 7 really, but if you go up to 10, it'll be okay. All right, so next thing we're gonna do is we're gonna throw this thing in the chuck, all right? Notice a few things. One is that we're using a 3-jaw chuck, so we don't have to self-align, or it's self-aligning, so we don't have to align that. Also, the distance we have sticking out, we're using a 1-inch threaded rod, or we're gonna thread a 1-inch rod, so I have it sticking out no more than 5 times its diameter. That way we don't have any deflection here at the end. We still might have some, so we're gonna really just take it slow here, okay? We're gonna go ahead and we're gonna face this front here, then we're gonna come to the back, probably about right here, and we're gonna cut the relief. And that relief is gonna be for when we stop our threads, we don't break that end off, okay? All right, so like I said, first thing we're gonna do is we're just gonna face this part. I went ahead and did all my adjustments to make sure that the tool height was set perfect. I'm taking a pretty big cut here. I'm running at about 650 RPMs. For doing some of these cleanup stuff, that's just fine. Yeah, not bad. Let's go ahead and we're gonna do one little cleanup cut just to really clean that off. See how smooth it is. And I'm doing this one a little bit slower. Ah, perfect. All right, I just wanted to show you one quick trick for how to measure the distance back from the front face here. First thing we're gonna do is we're gonna come up and just barely touch that insert against this side. Right now, I would go ahead and reset my DRO or my digital readout. We were gonna back it off. We're gonna come over the width of this blade. I think it's like I think it's 0.125 for some reason. So we're gonna come over, hold on just a second. Yeah, it's about 2.125. And then we're gonna re-zero it out right there. And then we're gonna go ahead and travel the distance down that we want. So we're gonna do let's do about 2.5 inches. Here is right about there, okay? So that would be the quick trick to set it so we know exactly we have 2.5 inches in front of our blade here, all right? All right, so now we're gonna go ahead and cut that relief groove. I always like to run mine a little bit slower than the average person, let's say. We're gonna go ahead and run at about 35 RPMs. I'm just gonna go ahead and click that in. All I did was spin the chuck to give it that to go into gear, all right? Wanna make sure we're adding plenty of oil. Man, that brush doesn't look too good. We're gonna go ahead and fire it up. Oh, that's maybe a little slower than I wanted. So let's go back up to 75. All right, I can handle that. And we're just gonna slowly start feeding it in. Let me get to there. All right, there we go. Obviously, this one's not quite round. One of the main things I want you to notice, if you haven't done a lot of parting, is how the chips look. Notice that they're coming off in really big splintery ways. Let me go ahead and I'm gonna zoom in. Still can hardly see that, huh? See how big those chips look? And just constantly be adding oil. All right, so very rarely do we have a relief that is exactly the width of that blade. So what we do is if we come over the width that we need to, and we just plunge in again, okay? You gotta be careful because now we're not using that full blade. It could deflect. So to do the scratch pass, we gotta blue this area. That way when we come across it, we make our scratch pass, we can test it with one of the thread gauges, all right? So the first thing I'm gonna do is we're just gonna spray. Be very careful, you don't need a super thick thick blue coat. You just need a light one. Try not to spray the chuck like that either, you know. This stuff's hard to get off. All right, perfect. So we're just gonna let that dry a second and then we'll get back to it. All right, a few things with the controls I wanted to point out. One thing, there's a screw or bolt right here. It's got a little flappy, I don't know, flappy handle to it. You wanna make sure that's locked down. Now, some of the videos you may watch, I think even one I'm gonna link in below, is going to use the cross slide. You're welcome to do it that way. It's not the way we do it. The reason they do that is mainly, I believe, for bigger threads, some odd cut type threads. They put less of a chip load on a piece of carbide. We're going to be using our regular access here, and we're just going to be moving it in. The reason I like to do this is because it just takes a lot of the guesswork out of it, a lot of the confusion. You can use the digital readout, things like that. It just makes it really simple. So make sure we only are operating with this. We're not using this cross slide at all. If you'd like to do it the other way, we can talk about that, but I personally would recommend doing it the way we're going to show you in this video using this, okay? There you go. All right, guys, so next thing I want to do is we're just going to take and we're going to do a light bump on that piece of metal. I've already done my tool height alignment, so we're just going to go ahead and we're just a light bump. We're really just trying to tell it has resistance. All I'm going to do is going to come to my DOR, my digital readout, and we're going to set it for 0. Okay, so now we got our digital readout zeroed. We're gonna go ahead and back it off, and we're gonna bring it over, and we're gonna go back to that 0 point. I'm gonna actually go in about, we're actually gonna go in about 3 thou, all right? That's 0.003 for all those people that are kind of new to working with decimals like this, okay? So a very light cut. Now there's two main controls down here that you wanna work with, and this one is this little black knob, and this lever right here, and this was the lever that engages it. We're going to go over that one in just a second, but this little knob is the one that we're going to be using the most. Now notice that there's 3 different settings for this one. The first and the last one are used for the automatic feed. It's the center one we want to be working with. So if it's all the way pushed in, it'll actually automatically feed the bridge in and out, and if it's all the way out, it'll go lengthwise, okay? But we want it in the middle, so we're just going to pull it out. It's going to pop once. If you go all the way, it'll pop twice. So we'll go back to that center. Oops, too far, right there. And if it doesn't go in, just try to rotate this knob around. So the lever that I will be using will be this one, not this one. This one's for your automatic feed. We're going to be using this one today, all right? So the last thing that we really need to watch for is we need to look at this dial here. It's located to the right of the apron or that bridge, okay? So what we're doing is when it comes around, this thing's rotating and it's going to tell us where we're going to hit the threads at, all right? And we're going to be watching these numbers, and we're going to always start on the same number. Now that means if we pick number 4, we can start on any of these number 4s, and I'm going to show you how it works here in a second. Typically, if you're cutting an even thread of an even amount of threads, such as 14 threads per inch, you're going to use an even number. If you're cutting an odd amount of threads, you're going to use an odd number here, all right? We're going to go ahead and engage when it comes around to the number 4. I start lightly adding pressure when it gets close, okay? So I'm adding pressure, pops in, okay? Now it's automatically feeding. You can see it's actually moving along pretty quick, and we're not going to cut for this pass. I'm just trying to show you guys just how fast it's moving. This is a pretty good clip. Now remember, the higher RPMs you use, the faster it's going to be traveling across that piece of metal. Either way, it doesn't matter to me, it's just what you feel most comfortable with. Okay, so one more time, kind of a higher wave view here. We've got this thing spinning around. We're going to go ahead and watch till a 4 comes up here. It's right there. And we're going to go ahead and engage, and then we're going to notice that this wheel right here starts spinning. And that's causing it to travel down. And we're going to go ahead, once we get to the place that we like, we're going to go ahead and disengage, okay? Now, quick tip here. If you're working with this, try to leave your hand on this knob the whole time, because a lot of people will switch and they'll grab this knob and they'll try to turn it off and it won't work. So just kind of leave your hand on this knob at all times, all right? All right, so now we're going to go ahead and we're going to do our scratch pass. We're going to go through the process we just showed you about how to push the dials at what time. So here we go. So because we're working on an object that's not perfectly round, it's not cutting all the way around. It's only cutting some of it. That's all right.
Hopefully you guys will be working on an object like this.
And we pull that knob or that lever up as soon as we get into our relief, all right? And then we're gonna go ahead and we're gonna zero it out on the DOR. We're gonna back away. We're gonna go ahead and turn off the lathe, and then we're just gonna check that scratch pass. So we're gonna take our thread gauge right here, and you can see I've already got the 14 out, and we're gonna make sure that it lines up with all the points of that 14, and this one looks pretty dang good. Because you remember, like I was saying with some of those gears, they sometimes like to pop out, and they will even pop out on you while you're traveling along cutting your threads. So now it's just a process of coming in 3 to 5 thousandths more each time we make a pass. So, and remember, I zeroed it at the end of that last one, so we're going to come in another 3 to 5 thousandths. We're going to do 5 thousandths to begin with. All right, so now it's just a process of repeating over and over again. So what we're going to do is we're going to turn it on, and then we're going to wait till the number 4 rolls around again, and we're going to go ahead and engage it. All right. So now you can see we're getting a good scratch all the way along. You want to make sure you're adding oil constantly, all right? This is a very oily process. Make sure it's got tons and tons of oil on it. We're just going to repeat this process probably 30 or 40 times until it can have the nut can fit on there, all right? So I got my nut here, and I'm just repeating the process till this thing can thread on nicely. So just keep that in mind. That's a good test indicator. You can use that thread gauge too, but I kind of always refer to the nut. One thing, as you're watching from this view, I want you to watch how many times I go in and I re-zero this thing out. After each pass, I re-zero it. That way I don't have to do any counting. Not bad at counting, I just don't, I get tired of it, you know? So we're gonna go ahead and keep going. So went ahead and just stopped it mid action here when it was in the groove over here. That way we just don't even have to restart. We don't have to do hardly anything. Ooh, and those threads could be. Let's go ahead and brush them out a little bit. They might be perfect. Oh, they are. Just kind of dirty. And all we're doing is we just keep test fitting it. So let's see how this one works. Oh man, let's turn down. Okay, so it's getting kind of tight here. So we're gonna go ahead and we're gonna do another 3 thousandths, and then we're gonna check it one last time, or if at that point we'll do another one maybe. So go ahead and restart it. See if it's gonna fit on again. A little bit further that time. We'll go ahead and do at least another little bit on there. Oops. Now one thing you gotta think about is we've been running this pretty good for about the last hour, 30, 40 minutes actually, but it's pretty warm. So once it cools down, it's actually gonna shrink a little bit more. So we're gonna do at least another, we'll do another probably another 3 thousandths off this. And then if it doesn't fit, then I'm gonna let it cool and then try to fit it and then do one final cut, okay? That was a really nice cut. I hope it's perfect here. I wonder if I just got crap in it because it's going on less than I did before. That's just gonna clean it down with some WD-40 just to get rid of any junk inside there. And I got the emptiest can I could possibly find. Jeez. All right, so I think that proves it. Threads are good. I think we got some chips in here. I'm having a hard time actually getting it back off. Ugh. Hopefully it cools off too, and yeah, we'll get the chips cleaned out of there. So that completes our lesson here on threading on the engine lathe. Now, originally what I said was about 40 passes, but I think I only did about 15 to 20. I like to keep them around 7,000s. You can go up to like 8 or 9, but definitely for some of those finishing cuts, you want to make sure you do 1 or 2,000s. It definitely it adds to the cutting quality. Okay. And remember, like I said, if you want to run it faster, you're totally welcome to, but I personally feel the most comfortable at about 75 RPMs. I think I have bumped up to about 110. It seemed to work pretty good. Otherwise, there shouldn't be any problems. This thing took me about 2 hours to do, so if you are planning on doing it, you want to make sure that you give yourself a solid block of time, because you can't stop. You can't pull your parts out. You can't adjust your tools or anything like that. Once you start, everything's locked. You got to keep your part in the chuck the exact same way. You have to keep your tool the exact same way. You can't move some of the cross slider stuff around. It all has to stay identically the same. That way it always meets back up into that path, all right, or back up into that thread. But that's all we got for today. Good luck. Hope you guys' projects turn out.